So now that we're done with the majority of the homework, we have chem homework to do, which I think we could do a little bit of that. But I'm thinking of doing more physics also, so we will juggle those sooner or later. I think um, well, majority of the time, I don't know what we're doing actually. We'll just figure it out as we go. But I think I promised chem somehow. And the best thing I can do is right now is talk about macroscopic level. Then obviously, if that's true, there's micro, and there's another one called simple. Um, I could go on like that, but yeah, I don't see the real point of that. We could talk about chem in its entirety, and we still will be confused to the end. And I'm doing homework problems. Why should I do chemistry right now? When it's really not helpful to me until like 1 month from now, um, because that's when my final hits, and I am looking for 100% on that because I screwed up the midterm heavily. Um, we could go over midterm problems, but I don't see the point in doing that. I mean, sure, it might be fun to do. I mean, we could talk about what is the definition of macroscopic and microscopic level and what's the difference. Obviously, macro is big, large, and micro is little, like atoms and actual chemistry we're doing, and qualitative is like descriptive activation, and quantitative is numbers and measurements. The important part is measurement, but in the substance, and then a solid, liquid, gas, and property change and property chemical property, and then the electron, proton, neutron, electrical charge, and then we could talk about mass number. We could do all that shenanigans if we really deemed it necessary, but I think it's better to move on from that, cycle and go to physics, or alternatively, we could do some um, math 18, just because it is my quiz is coming up soon. So, whatever the case is, we are still doing homework problems. Well, unless you want to talk about matrices and how they functions and doing graphs, which would be fun. Totally would be fun. Or we could do more homework questions. That's what my brain is thinking right now. And how much time do I have wasted talking about this shit? 2 minutes. That's pretty okay when you don't know what you're gonna do, um, which is fine. I think we're gonna start off right now. So I think do I want to do arc linked? That's boring. Polyatomic atoms. We could do that too, actually. Or we could do homework questions. I think I did a little bit chemistry, so I think I would dive a little bit more to chemistry. Half of this would be chemistry, I guess. Then that's fine with you. That's fine with me. So chemistry is the study of atoms. Study of the microscopic level. Macroscopic, I'm not going to actually write scopic. This just means I'm just going to go forward and say, yeah, I hope I know what I'm talking about, macro. And then scopic, I hope you know how to spell that. So it means dealing with large objects. You might be thinking, well, why are we um, doing this if we don't need it. What I mean by that is, don't we need to focus on the math first? Normally, you do in chemistry honors in high school, but in college, they care a lot more about definitions for some reason, depending on your teacher. Which is bullshit in my opinion, but um, apparently that's how it works. So I'm gonna stick with that shenanigans, even though I don't agree with their what they're driving through my neck. I'm okay with it. I'm just being a little hard judgmental on it, too much on it. I think it's pretty good that he has definitions and cares a lot about it. In some cases, but I think I need to get my midterm help sheet out. Um, Wait a second. Let me get my high. Where is it? List of terms in a lecture by Olivia Hopkins. He wrote it. She wrote it. It's being downloaded as we speak. Oh, I already downloaded a long time ago. Okay, so we can actually look at the shenanigans, and we can go start one by one. Um, we will start pasting it, and but from my memory, let's see how far I can get. We'll start with these terms because that's fine. Um, sure, it will backfire on me. Start with these terms right here. Um, and we'll keep on going on. We will we will keep on going on and on to different things. Chemistry is the study of atoms. Macroscopic is dealing with large objects, dealing with very small atoms. Actually, we could just get rid of dealing with atoms and small stuff. That's a very bad definition, but chemist um, symbol for different elements and objects, I guess. So like N for neutrons and other stuff also works. The quantitative, the no one uses, no one likes it. It is the um, observational description. I think that's the best way to describe it. Quantitative, physical world loves it. Physical scientists, modern scientists. We should probably not do that. Physical science loves this. This is more attuned to quantitative. So, yeah, it's using counting to measure something, to the best way to describe something or something. Describe. I don't know. A scientific method is a defined way of solving something, way of experimenting. Because experimenting would work. Experimenting, I can just go over here and just tell me. It's highly controlled and tested. Wait a second. Why is it not going away? Highly controlled and tested um, observation. Observation might work. Can be falsifiable. Um, a statement that is true. A statement that keeps on occurring and true. Keeps on occurring and true. I'm not gonna write all that. Scientific theory is a bunch of collections that are could be falsifiable and it's not proven yet. It's not proven basically. Like the evolution theory is like there's evidence for it, but it's not really proven outside of the scientific community. Like it's like scientific law, Newton's law of gravity. We know it works because it happens everywhere, and we have measurements to actually figure that out. And this is like loose dot points to figure that out, which means that's how other people question the theory of relativity and other stuff because there's proof of it, but there's not proof everywhere that is true. You know, Significant figures is a rounding, trying to fix a rounding error or something like that. Really ridiculous how to describe that. Okay, that was awful, but yeah, still doable. I need a better way to describe some of these. So save as two audio users. I don't care if I replace it. So models are next. I accidentally did a screenshot it. Some models I'm putting it like that. Well, the rest of it I can actually just import it. So this will cover the first page and basically the first two models are scientific models that try to prove something in the what's it again the what do they call it again? Scientific experiment. Oh, what's this working? No, scientific method. They use models to prove something. Yeah, substance is a pure form. A pure form. That's the important part. State of matter: solid, gas, and liquid. This is not enough description. You could go beyond that, and actually, that's what you should do. Physical property is the ability to change. Ability, not the change. Physical change is actually the thing that's happening, and physical property is the ability for that to happen. Important difference. I got it wrong on the midterm because of that. Really not important, but important for this class. But yeah, Chem 6A cares a lot about the shenanigans. SI units are like kilograms, and the standard units from well, scientific notation is like a notation that we used. Uh, that I'm pretty sure you don't need a definition for it. Unit derived units is like meters per second. The bullshit definition again. Density, well, that's not the bullshit, and that sucks. That is the volume, I believe. What's density? I forget. Is mass divided by volume. Yep, I was half right. Mass divided atoms is from the Greek word unbreakable. That is, atom is consists of protons, neutrons, and electrons. Precision and accuracy is something you need to do a 3D chart for. Think of this as some kind of I don't know how to describe that. Accuracy is like hitting a point like multiple times, while precision is getting it right in the middle, getting the answer right. Exact numbers is without scientific notation or scientific sig figs. And sig figure can be written as sig figs or shortened. Well, was that 10 minutes? Because I'm done talking about the shenanigans. Because it's kind of useless to talk about. All right, we have done 10 minutes of this. Okay, said I would. So we're gonna go with physics next, which should I do physics next? Wait, no. You know what? Why don't I stop this video in chem? While we're talking about chem, we can also talk about how atoms are arranged. H plus and H minus, whatever. Um, and this doesn't need to be here. H plus means that there is a proton, and because it's like one, so it's like a positive charge, and the electron is negative charge. It's in a cloud, so it's not really rotating. It's like a cloud of field, like this somehow. So we'll stop here because I think there's a better way to describe this than what I'm already doing. So I thought I was gonna stop, but I think I should stop when I'm done talking about everything I need to talk about. I mean, when the 20 minute mark hits. So we're still continuing our rampage through chem. So the next part is about elements, and then John Dayton atomic hypothesis. John Dayton made the atomic hypothesis, this idea that I forgot what that is. Don't really give a crap. Electron. Oh, electron is E plus and an E plus charge. So a proton is P, and an electron is an E, and a neutron is an N. Subatomic particles are distinct subatomic. Atomic number should be, I mean, the easiest way to write that is atomic, the number sign over here. This means number, so figure, and then mass number is, so if I have an atom here, usually you have the mass down here, atomic a mass number and atomic number at the top. But atomic number is amount of protons that defines the atom itself. Well, the mass doesn't do that. The mass is weird. It just shows. Oh. And funny enough, all of this tiny shenanigans somehow create the everything in our world. And once you realize that, it turns amazing. Though you understand that this world was created on all these ideas in that you never really thought about. Atoms, basically. Kind of hard to describe sometimes. I'm starting to realize it might have not been my best idea to use this system for chemistry, especially since it's not one of the greatest ideas I ever thought about. I'll admit that much. Um, but what to actually say here actually infuriates me because I don't know. No, because it's literally very simple. Concepts or something. You know what? Why don't we do chemistry homework? You know what? I give up. I was not gonna do chemistry homework because it's a bunch of pain in the ass, but yeah, I think it's just gonna turn to chemistry homework time. Yep, it turned out to be my best choice in the world. Yay, we're doing chemistry. Wait, why don't we just start with one? So, it doesn't really help, does it? Um, Ethanol, common element. So if it has a density of 0.789 grams per ml, what is the mass? If the mass is in grams, so 139 ml of a certain something, it can be a molecule, whatever. What is the overall mass? You would assume to proceed to do this. 9 ml. And then you cross this out and you get the answer, which turns to 110 something. Cool. I already did this homework before, so it's not hard. Actually, oh, there's a homework I didn't do. Didn't finish. Okay, never mind. We're going to start with that one then. So electric configuration of Mn, so we'll get the periodic table. I know what to do with the periodic table because I listen. Magnesium or magnesium? Magnesium. Okay. So one thing to know is, can I do a shortcut? Oh, I can't do a shortcut. Okay. I'm sick and tired of not doing a shortcut. Okay, it's gonna be pain. Um. Oh wait, I need to erase that. 2p6, right? 2p6, and the next one is 3s3, 3p6. Then we have 3. Oh, this might be actually a trick question. Where is this at in the periodic table? That's 25, so that's 25, 25, what did they call it again? Electrons. So how many of these electrons are get rid of? So 2, 2, 6, 2, 6, and then about to get rid of something more, which I don't know. So it's 4, S2, and then we have another one, so on. But we need to make sure this is actually accurate. 10, go on, 12, come on, 18. So 2 more is 20, and here our table says 1, 2, 3, 4, 5. 5 right here is 25. Yes, so it works. So just to make sure that sometimes it doesn't collide to the whole thing, so you have to go back here and get rid of these two and go up here. It gets not up here sometimes. So, and then we drop down to 2D, 3D, and then 1, 2, 3, 4, 5. So that should be the electric complication. So let me write that down. Um, uh, no, square root of 2s square root of 2p square root of 6, and then do this, and then do 3s square root of 3, and then 3p square root of 6, and then we do 4s square root of 2. And then 3d square root of 5, and let's hope that's the right answer. If it's wrong, well, we know I screwed up. I did something wrong, didn't I? Let's look at this question one more time, and actually, no, I did not. 1, 2, 2p, 3s, oh, I just typed wrong. How did I get that answer there? I don't know. I'm gonna give a fuck. Because it is my oh no, that's a mistake on my part. I'm just typing it wrong continuously. I don't think that's a mistake over here. Yeah, so I did make a mistake here. 2 over here, not 3. I made a mistake here, and then that's what caused it.